problem today. Today we are going to try number 808, soup servings. And many people don't like this question, even for many people don't like it. But I think this is still a good question. Yeah. So basically, the description is very confusing. But let me explain it just a little bit about the description. So it means there are two types of soup, A and B, and for each of there are four operations for serving the soup. So the first one is serve 100 milliliter of soup A and 0 of soup B, and second is 75 to 25, and third is 50-50, and the fourth is 25 for A and 75 for B. Yeah, but there are also some limitations. So for each of the serving, that is 0.25, it means 25%. So this is like a common sense. Yeah, if we choose each one of them, it is 0.25. Yeah, but there are also some notes. Yeah, if the remaining volume of soup is not enough to complete. Yeah, for example, if the remaining, maybe this is not 100, this is 99. So we're still gonna choose this one to for the soup A. We're still gonna take that 99. For example, if we still have 24, so for this choice, we're still going to choose. If A have 24, we're still going to choose all of them. Yeah, so this is the meaning. Only if we stop once we no longer have some quality of both type of soup. Only if we don't have A or don't have B, we will stop. Yeah, and here is another condition. And note that we do not have operations where all 100 millimeters of soup B are used first. So this means definitely A will used up first. Yeah, there's no such cases of B used first. So for this kind of a problem, we're gonna use DFS to search and plus the memorization to solve the problem. But there is also a Stack Overflow, because if we are use the recursive function for Python, if you calls more than 1000, normally you should have the Stack Overflow and return. We also need to take care of the return because the answers should be within 10 to the power of minus 5. Yeah, it is acceptable. So if it is more than that, it is not acceptable. And here we can also check that n. We know that n is a very large number. It can be 10 to the power of 9. Now let me explain it in the whiteboard first, and then explain my code in the code editor, because I'm not going to code it once again, just to put it here, and I'm going to explain why I coded it like that. Yeah. Now let me go to the whiteboard first. Yeah, so in the whiteboard, as I explained, this is basically DFS. Yeah, DFS like search and plus memorization. Yeah, plus the memo. And for each of the choice, for example, we have 50 of A and 50 milliliters of B. Yeah, each of them have 50. So what we're gonna do is we're gonna have 4 choices. Each of them will be 25%. Yeah. So the first choice is like A will serve 100, B 0. So this is just copied what the description. So A 75, B 25. Yeah. So for example, this is the first branch. The first branch, for example, A choose 100. So even A still have 50, we still take that 50 out, even because it is less than 100. So A becomes 0, or A becomes minus 50. Yeah, it is still okay. So here I use minus 50. It is still okay because I use this one to add to return for my branch to add the search from this point. So for A, 150 minus 100 is minus 50. Yeah. And for B, because 0, 50 minus 0, it's still 50. Yeah, this is the first choice. So what about the second choice? So for the second choice for the A, because A will use 75, but A only have 50. So what about that? So A serves 50 and it's 0. Or you can use minus 25. It's also the same. Yeah. Because minus 25 or 0, for me, it's the same thing. for my search. I just needed to check the conditions. So here is minus 25, here is a plus 25. Similarly, you can calculate all others. For example, A, B, 50, and here A used up 50, B used up 50, so it's 0 and 0. Yeah, for the last one, A used 25, so 25 left for A, and minus 25 for B. So these are the 4 conditions. Actually, for those 4 conditions, we have to check the descriptions. So if we still have if we already used up the A first, but we still have B, this is our first condition. Now let me go to the descriptions. Yeah, so yeah, let me check the return. Yeah, because let me check the return first. Yeah, because about the return. Yeah, so when we serve some soup, we give it to someone and we no longer have it. So each turn we will choose from the 4 operations. Yeah, so this is the equal possibility, 0.25. Yeah, if the remaining soup is not enough to complete the operation, yeah, we still serve. Yeah. Now we need to take care of these areas. So return, what is the return? It's the probability that soup A will be empty first, yeah, and plus half the probability that A and B becomes empty at the same time. So what is that? So here, for this one, A and B becomes empty at the same time. So what about the probability? So this is a 0.5. This is what the description asked us to get, yeah. And here, what about this one? A used up first, and this one A used up first, so this is 1 and 1. So this is why the description said 1 plus 1 plus 1. Yeah, because this is the first and the second bronze. Here is the third bronze, 0.5. Yeah, and then this one. So this one is the last condition. If B used up first, because it never happened. So this is why we need 2 plus 0. And for all of them, we should times 1 over 4 over 1. Yeah, so this is why they set it like that. So according to this, we can write our DFS function. Now let me go to the DFS function inside the code. Yeah, so here, as I said, I'm going to use a cast to speed up the search because I'm using m and n. So this m and n equals to this number n. Yeah, because we are going to use this number. This number n can be as much as possible. It can be 10 to the power of 9. Yeah, and here we are going to use the DFS. So DFS for those two numbers. So if A goes to 0 first, but B is not 0. So this is why the first condition is like this. Yeah, so we're gonna return a 1. Yeah, so if this A is less than or equal to 0, and this B is also less than or equal to 0, we're gonna return 0.5. Yeah, because this is what the question asked us to return. So this one never happens. This one is if this A is still positive. Yeah, we still have A, but A still have the soup, but B has already used up because it never happened. We're gonna return 0. Otherwise, we're gonna use this 1 divided by 4 times the 4 branches. So the first branch should be DFS m minus 100, and here should be n. Yeah, this is the first condition, this one. And then go to the second condition, it's m minus 75 and n minus 25. And then go to the third condition and the fourth condition. So this is basically the entire code without for the Stack Overflow. Yeah. Let me comment here because I'm not going to use this one first. Yeah, so let's check if this works or not. Because the Python stack and for any other language, it is like nearly 1000 maximum. Now let me run the code to check if it works and then submit it. Yeah, as we can see, it works, but let me submit it. We have a Stack Overflow because the Stack Overflow because it's 999 for the Python. Yeah, so it means it didn't work. We have to find some numbers. Yeah, because this is not possible to calculate a number big enough. For example, this number may be maybe, yeah, this is a very big number. The Stack Overflow, it is a source for any other language. So what we're going to do is, if this number n is very big, yeah, let me go to here. If this number n is like 10 to the power of 9, it's a very big number. What going to happen? It means we never come to this end. Yeah, because this is the return, because we never return. If this number n is infinite, yeah, for example, if this number n is infinite, so we're gonna always search, but we're never gonna return. It means the probability of this condition may be 100%. Yeah. So this is the intuition of this question. We need to think something about this. If the number is bigger, so the probability and possibility is also bigger. So we're just going to find this number, this n, maybe some number. Yeah, we need to find this number and get our result. Yeah. Now let me go to the code editor to find this number. So for finding this number, I'm going to use a binary search to search that number. But for searching the number, I'm also need to find two numbers that is close enough to check. Yeah. So for example, how should for me, I'm going to find this 4,000 and 5,000 for this number, because this is basically like a simulation problem. So we have to simulate and find some numbers. Yeah. Now let me find this number. So for example, if I give a n like 4,000, and here is also 4,000. Now let me check if I can get some values of the probability. Yeah. If this n is bigger, it means the probability is bigger. As you can see, this probability is nearly 1, but it is not our answer, because our answer is 0.999959, but here is only 49, because this is the accuracy of the requirement. So here, the requirement, it means 10 to the power of minus 5. Yeah. So how we gonna find this number? Maybe we're gonna try another value, maybe 5,000. Yeah. Now let me just run it to check if the probability is bigger enough. As you can see, it is nearly 100%. It seems this number for 5,000 is okay. So for here, you can check the numbers. For example, you are going to check some values. So if this n is more than 5,000, you can return a 1. Yeah, because it is a 1. Yeah, more than 5,000. Otherwise, you can return this number, n and n. Yeah, I'm pretty sure this should be okay. Yeah, now let me submit it to check if it really works. Yeah, as you can see, it really works, and it's nearly like 100%. But that is not what we're gonna do. We are not going to guess some numbers, because we're going to calculate which number it is. Here, we are going to use a binary search to find this number. Yeah, let me uncomment this. So here for the L pointer, maybe 4,000, and R pointer 5,000, definitely it is some number between this one. So here I use the binary search while this L less than R, and here is M, and here is the result. I'm going to call the function DFS. Yeah, DFS MM. If this result is more than this number, 0.99 with 5 nines, and the R pointer should equal to M. If it is less than or equal, so the L pointer should equal to M plus 1. Yeah, so in this binary search, definitely I can find this number. So if this n, so the result should be L. So if this n is more than and equal than L, I should return a 1. Otherwise, I'm going to return the result, DFS n at n. So this number, n at n, should be less than L. Now let me submit it. Yeah. Yeah, as you can see, it's pretty slow, because we use binary search to call many functions of this DFS. Normally, we should not do that. But here, I'm just going to find this number, find this L. Yeah, so let me find this L. Let me find this L first. Yeah. So how should we find this L? I just need to uncomment here and print this L. Yeah. Let's check which number should be. Yeah. Here I'm going to use yeah, here basically yeah, I'm just return anything else. It doesn't matter. Yeah, because I'm not going to return the final result yet. Yeah, but just let's run it to check this L. Yeah, now we find this L. It is a 4451. Yeah, it means if we choose this number, definitely it should work. Now let's choose this number. Yeah, and we should also delete the binary search, because for this kind of a simulation problem, we don't need to have binary search anymore. That is only for our calculation. If we use binary search to find this number 4451, yeah, so of this n more than or equal, we're gonna return 1. Otherwise, we're gonna return DFS n and n. It should work. Yeah. Now let me run it to check if it really works. Yeah. Yeah, as you can see, it really works, and it's also pretty fast. So this is the whole idea of this problem. Actually, it's pretty a good problem. I think even if it happened in the interview, a lot of ideas you can think. So you should use the DFS to search, and then you should use the memory, or you should use DP. But here I use the search and plus memo, and after that I'm going to use the simulation to find this number. For finding this number, I'm going to use binary search, but inside the code, I'm not going to put the binary search inside because it's not necessary. Yeah, after I find this number, I'm just to put this number and return my function. So this is basically the entire code, and the time complexity for this one, as we know here, we didn't take so much time. Yeah, and here we only use the DFS, and here because we use the memo, and this is like 4,000. If 4,000 divided by 25, it means it's nearly like 20. Yeah, if we use memo, it is basically if like 2 to the power of 20. Yeah, so this is why we can still pass. Yeah, 2 to the power of 20 is not a big number, so we can pass for this kind of problem. Thank you. If you think this is helpful, please like and subscribe. I will upload more Leetcode problems like this. Bye.